Some solved problems for Chapter 19. I have a current carrying wire. I know the current is going to be 1.6 amps. We're looking for how many electrons are flowing by per second. Well, I know that the definition of current is a flow of charge. So how much charge is going by per unit time. And in this case, my per unit time is simply going to be 1 second. So that tells me, well, how much charge? It's going to be 1.6 coulombs. I'm looking for electrons, and let's think about how much charge an electron has. One electron has got 1.6 times 10 to the negative 19 coulombs worth of charge on it. So I'll cancel those guys out. That tells me that I must have 10 to the plus 19 electrons flowing by every second. Problem number 5, given some current and resistance, what is the voltage? Straight up use of Ohm's Law, V is equal to IR, so 0.25 multiplied by 4800 tells me that my potential, my voltage, is simply going to be 1200 volts. For problem number 13, we know that we have some copper wire that's going to be 5.4 meters long. Also know that it's going to be copper. That tells us something about the resistivity. The resistivity of copper, we can look that up, be 1.68 times 10 to the negative 8th ohm meters. It tells us the diameter of the wire, so 1.5 times 10 to the negative 3 meters. Very simply, what we're going to say is we're looking for the resistance, and we know that it's going to be the resistivity, the length, divided by the area. It's going to be a cylinder, so the area is simply going to be pi r squared. So resistivity length divided by pi radius squared. So radius is just going to be half of the diameter. So resistance is going to be 1.68 times 10 to the negative 8th. Multiply that guy by the length, 5.4 meters, divided by pi. And then it's going to be 1.5 times 10 to the minus 3, divide that guy by 2, half of the diameter is the radius, square that guy, and we're going to come up with 5.1 times 10 to the negative 2 ohms. And for problem number 27, I have some potential from a portable CD player. I know how much current it's drawn, asking for what is the maximum power consumption, and I know power consumption, I can write that as the current times the voltage, so it's going to essentially be 240 times 10 to the minus 3 amps multiplied by the potential 3, and I'm going to come up with 0.72 watts. If you've ever used a hairdryer, you might know, hey, it's got two settings, low setting and a high setting, and you plug it into the wall, it's going to have 120 volts. So, which one do you think the resistance would be higher at? Since we know that we can write the power is going to be the voltage squared divided by the resistance, we could just as easily write the resistance is going to be the voltage squared divided by the power. Since I'm trying to guess which one the resistance is higher, essentially I want to divide by the smaller number. So I would choose that one. Let's go ahead and calculate it out. So 120 squared divided by 950. It's going to give me 15.16 ohms. Now let's take a look at the higher power setting. 120 squared divided by 1450. It's going to come up with about 9.9 ohms. And much like we expected, 950 watt one is going to have a higher resistance. And lastly, let's talk a little bit about AC voltage. We know that it's going to have a peak value of 180 volts, and it's across some resistor. We can solve for the peak and the RMS current. The peak current is simply going to be equal to the voltage, the peak voltage divided by the resistance, and so that's going to be 180 volts divided by 310 ohms, so 0.58 amps. Now the RMS, essentially what that's going to be is the root mean square, and that's related to the peak voltage simply by dividing by the square root of 2. So going to take 0.58 amps, divide that guy by the square root of 2, and come up with 0.58 0.41 amps.